Hello, good morning everyone. I am Dr. Vikas, Tomar, scientist, Central Groundwater Board, Uttaranchal region, Dehradun. So today we are here in National Institute of Hydrology, Roorkee, participating in International Groundwater Conference 2025. So we are here in exhibition and we are demonstrating few of our studies which we are doing in Uttarakhand region as well as throughout the India. So this is our working model of Springshed management, how springs in the hilly regions exist and what is the mechanism of these springs, how they are getting recharged and what are the interventions and management plan we should take up while addressing the issue of depleting discharge of these springs. So this is a typical working model. You can see here during the monsoon season, monsoon runoff, we have to basically arrest the monsoon runoff, so that the water gets more time to get infiltrated, and through the porous media it can again come out in the form of springs. And since in hilly regions there is no other source of water, means habitat is there in the hilly regions where these springs are existed. So this is a working model. We have shown how geology is important. Like you can see the bedding plane, the subsurface strata is dipping towards this side and our springs in this valley. So for revival of this spring, we should have our recharge structures to this side of the valley. Not this is different from watershed approach. It is a Springshed approach. It is a valley to valley approach. Whereas in watershed we have ridge to valley approach. But in this we can see by studying geology of that area, we can see that these springs are fed up from the other valley only. So this is our model. We have undertaken Springshed management project in collaboration with NIH and Survey of India, through which we are doing the Springshed management activities in this Tehri Gadwal and Rudraprayag district of Uttarakhand state. And we have already completed Bilangna block and Pratap Nagar block of Tehri Gadwal district, and this year we are taking up Ukhimat block of Rudraprayag district. For these completed studies, we have already mapped all the springs present there, and we have also conducted geophysical surveys to delineate the subsurface waterways for these springs and propose the interventions in those areas. And again you can see this is the heavy metals present in groundwater, how they can affect our human body. So this is self-explained. You can see how iron is impacting like stomach problems, and this chloride and sodium is getting higher BPs, and fluoride you can say dental. And so this is a typical model showcasing TAM, means electrical resistivity through multiple electrodes. Through these are the electrodes, these are current electrodes through which current is passed into the subsurface, and this is non-destructive method. Since drilling is a costly affair, so before prior to going drilling, we can have this type of survey, so to delineate the potential zones, subsurface zones in that area. Through this we have multiple electrodes, and through these electrodes we can inject current into the subsurface. At one single time 4 electrodes are being displayed here, and we can get lateral as well as vertical resistivity contrast, and we can pinpoint our site for artificial recharge or for extraction of groundwater. Then this is rainwater harvesting and artificial recharge, how it is made mandatory by government in most of the states, and how individual families, can use it in their homes only. So this is a typical rooftop rainwater harvesting. You need to have a roof, and from that roof we have to collect all the water during monsoon season through this like channelize like pipes, and then we have to store them, and through making some bore holes we can inject that water, surplus water during monsoon season into the ground. So it will artificially recharge the groundwater resources of that area. And then this is again like in some areas where water quality is not good, like in arsenic contaminated aquifers, because we all know that throughout the Ganga plains we are having this arsenic problem. and this arsenic is present in the shallow aquifers only. So what we can do, we can have drilling in this area to assess the fresh groundwater beneath the impervious clay formation. So we have to first find out at what depth we are getting clay layers, and we can puncture that clay layer, and below that aquifer, through that aquifer we can have water supply to the area. Our arsenic contaminated, how to explore our arsenic affected areas and how to get fresh water in those areas. And this is our model of rig, DTH rig, through which we can explore groundwater